Welcome back as we finish up the chapter on applications of integration, and I hope you've enjoyed finding all the volumes and spinning solids around various axes, and of course the shell and the washer game. Those are good problems. This average value of a function, it's you get asked this a lot. The question comes up over and over. Very easy. If you're looking for something easier, you've come to the right section here. So this can be a short video, I believe. I can work some example problems. But 6.5 6.5 is called the average value of a function. What are we doing here? I guess I should get green. Here's a function here, f of x. We get this f of x. And a little curve goes from A to B. Average value might be, average value somewhere. If I'm guessing, the average value of this thing kind of might sit right there, right? I might say that's the average value of the function. Okay, so you might, there's different ways to do this. I guess I can do this one way. Here's the way I used to do it. Let's continue with that. If you found the average value of 5 numbers, let's start the average value of 5 numbers, how would you do it? Well, you'd add up the 5 numbers and divide by 5. So, you might do something like this. X of I equal 1 to 5, and you divide by 5. So add up the numbers, divide by 5, that's going to give me X average, right? Well, how are you going to find an average value function? You're going to add it up. How do you add up a function? How do you add up a function? Well, how about this? You integrate it. You add up a function, you integrate dx, all right? I'm going to add up the function from A to B. Well, what am I going to divide it by? I'm going to divide it by the interval. 1 over b minus a. So the analogy is kind of easy to remember. Here is, average 5 numbers, I do this. To average a function, I add up a function, I divide it by the interval. And when you think about that pictorial, and maybe this is a good way to show it too, if I got this average value here, right? This better be true that the F average from my picture, that's the average height of the rectangle times B minus A. That's going to give me an area, right? That better be equal to the area under the curve. So here's another way to remember it. The area, this is area here, right? The area. These better be equal, right? And so then what does that, solving for that, you'd say, well, F average is equal to 1 over b minus a times the integral from a to b, f of x dx. Okay, there you go. Easy thing to remember. Let's work some problems from the book, shall we? Maybe we'll remind ourselves how to integrate a bit. Okay, I'm back to find average value, and since the concept's so simple, I thought I'd pick some maybe a little bit more difficult integrals to remind you of a few things. So the first problem here is, let's see, number 4. I'm on page what, 377, number 4, and this one here is number 6. All right, so the first thing, they want to find the average value of this function from 0 to 2. Well, I'm just going to write down what it is. The integral is going to go from 0 to 2. I add up the function of x squared, square root of 1 plus x cubed dx. I divide by the interval, 1 over 2 minus 0. Okay? So then I got to remember, well, how do I integrate this? Wait a minute. Oh, I see the derivative here. I see the derivative. Oh, this is a u substitution. Ah, now you know why I picked it. A little reminder, u substitution. U is going to be equal to 1 plus x cubed. Du is 3x squared dx. Du over 3 is equal to x squared dx. Okay, there you go. I got the knockout. Now I'm going to do a change I'm going to do a little change here. Notice this is x. This is x. Why is that? Let's go back to red. I'm integrating on x. I've got an x and an x. Well, when x is equal to 0, u is equal to 1. When x is equal to 2, u is equal to 9. So this whole integral becomes 1 to 9. I'll get the 1/2 out here, right? That comes down here. X squared dx is du over 3. This is du over 3, and this is just the square root of u. All right, that's my new integral. Bring that down here a little more. This is gonna be 1/6 u to the 1/2 power du from 1 to 9. Okay, I got this one, I think. This is going to be u to the 3/2 times 2/3, right? That's my power rule. I got the 1/6 out here. And now I'm going to evaluate it from 9 to 1. Ooh. I'm going to extend that page some more. This looks like 1/9. 9 to the 3/2 minus 1 to the 3/2. Okay, what's 9 to the 3/2? Well, 9 is 3 squared to the 3/2 minus 1. I got a 1/9 out here. I don't know if they're going to let me extend it anymore. This is what? If I multiply 2 times 3/2, this is 3 to the 3rd power minus 1 over 9. That 3 to the 3rd power is 27. This looks like it's going to be 26/9. Check that in the back. Oh, this is an even problem. Okay, I think that's right. You can check me though. 26/9. 26/9 means that is equal to the average value of that function over that interval. Okay? Okay, now let's go back 7 minutes. We're going to find this one here, and we're going to do what? We're going to integrate. This is problem 6. I'm going to integrate. Oh no, the secant squared. What the heck is that? Oh, then there's a theta over 2 in this thing. Okay, and I'm going to integrate from 0 to pi over 2, and I'm going to divide by that interval, or pi over 2. All right? We could use substitution again, unless you can see it. It's just, you don't see this theta over 2 is a little bit of a problem. I'm going to make u equal to theta over 2, then du is just equal to what? Du is equal to 1/2 d theta, or 2 du is equal to d theta. So then this whole thing becomes the secant squared of u times 2 du, right? That became that, times 2 over pi, right? This just flips. Now, what am I going from? Well, I'm going from 0. When theta equals 0, that's 0. When theta is equal to pi over 2, this is pi over 4. Here's my new integral. You got to be able to do that change. Okay? When theta is equal to pi over 2, u is equal to pi over 4. Okay. Rewriting this, and I got to get rid of red, huh? Let's go to blue. This 2 comes out here. I'm going to get 4 over pi. 0 to pi over 4. Secant squared of u du. What's the antiderivative of that? It's just something you need to know. That is the tangent of u. The derivative of the tangent is the secant squared. I'm going to evaluate that at pi over 4 and 0, and I've got 4 over pi. Okay, let's extend this down a little more. And what is this? This is 4 pi times the tangent pi over 4 minus the tangent of 0. That is 0. That is 1. All right, so this whole thing becomes 4 over pi. That equals F average. Okay, two different problems, two different work. I had to use substitution both times. I had to remember the easy value of the average value. Now remember, here's the simple. This is worth 3 points on an AP test, and here's where you make your stupid errors. Let's circle this in hot pink. This, you got to remember to divide by the interval. You'll forget that. You'll do all this great work, did all this stuff, and you forgot to divide by that. So you'll be off by that factor. And trust me, on a multiple choice test, yes, that wrong answer will be there. Okay, so you find the average value. You had to remember how to do substitution, how to change the limits. Had to remember how to do that. Had to remember what the derivative of the tangent was, that it's the secant squared. And here we had to do a little more sophisticated substitution. Okay, hope that wasn't too confusing. See you soon. Bye-bye.